Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to find the area of a region bounded by y equals 9 minus x square and y equals 0. And we have to use double integral to find the area. Now notice, since it's a region bounded by these two graphs, the first thing we should do is figure out the points of intersection of these two graphs. So how do we compute points of intersection? And we can compute that by setting the two equations equal to each other. So if we set y and y, they're the same, so you set the right hand side of the equations equal to each other. So 9 minus x square is 0, which means x square is 9, which means x is plus or minus 3. Now it's best to try to graph these curves first and understand the region, and then we will set up our double integral. So notice the first curve is a parabola, because y equals x square, that form, and x square has a negative sign, so it will open downward. Also we can figure out, see, when x is 0, y is 9, so that's the y-intercept, and the x-intercepts, that's where these two curves intersect, and we found out our x-intercepts right here, plus 3 and minus 3. So if you come here, our parabola will look something like this. Now what is the region whose area we have to find? See, it's the region bounded by the parabola, and y equals 0 is x-axis. So it's the region between them, right? So we have to compute the area of this entire region between the two curves. Okay. Now think about how to set up the integral or the double integral. So we have to draw a representing rectangle inside the region, find the x bounds and the y bounds first. Notice carefully this particular region. Look, it's very symmetric to the left and the right side of y-axis, and it is symmetric, which means the area of the region, if you consider just the left side of y, that area is going to be equal to the area of the region to the right side. So why don't we try to compute the area of just the one side of y-axis and then multiply it by 2, and we'll get the entire area. So let's do that. Let's only concentrate on this region, to the positive x-axis, okay? And draw our representing rectangle there. And I choose to draw it vertically, which means I want x to be my outer variable. So see, the width is delta x. Okay, so let's just use that region and find the bounds. Okay, so what are the x bounds? Okay, look at the rectangle. Here is x, and only this part of the region, right? So it's from y-axis to x equals 3. So x is between 0 and 3. Okay, what about the y bounds now? Now look at the length of this rectangle. It's from x-axis up to the parabola. So y starts at 0 and till where? Till this curve, and the curve is given by 9 minus x square. So y is between 0 and 9 minus x square. Remember, these are the bounds only for half the region, and we have to double that. Okay, so let's set up our double integral here. So area will be computed using double integral. Remember, the outside variable is x, so the outer integral will have the x bounds 0 to 3, and dx is the outside one, and in the inside we have y, so 0 to 9 minus x square dy. Okay, notice that the bounds are all written correctly, and this dy dx, it actually gives us the area of this one representing rectangle, right? Dx is the width, dy is the length. And integrating means basically adding. So we are adding all the areas of all these rectangles in the entire region, the half of this region. So that gives us the total area. So this is correct setup, but this is only going to give us half the area, remember? So to get the entire area, we just have to multiply it by 2. Okay. Now let's compute the integrals. First, keep the outer integral as it is. Don't do anything. Just focus on the inner integral. Now inside we have to integrate dy, and the integral is just y, and evaluate from 0 to 9 minus x squared. Keep dx as it is. Okay. Now plug in the limits, 9 minus x squared for y minus 0, and then you have dx. So you just end up having 0 to 3, 9 minus x squared dx. Now it's just a single integral, and we can evaluate that easily. All right, now 9 dx, integral is 9x, minus x squared dx, using power rule, is x cubed over 3. And then we have to evaluate from 0 to 3. Okay, keep the 2 as it is. We plug in 3, so we get 9 times 3 minus 3 cubed over 3. Minus, when you plug in 0, look, both terms has x in it, so both of them will be 0, so you will get a 0. Okay. Okay, so we end up getting 9 times 3, 27, minus, this is 3 cubed is 27, 27 over 3 is 9. So this is 2 times 27 minus 9 is 18, and 2 times 18 is 36. So the area of the region bounded by the parabola and the line is 36 square units. Thank you.